Hi, my name is Sagi Volkov. I'm a performance architect at Lightbits. Welcome to my virtual KubeCon session. We're going to be talking about how to test your storage performance in Kubernetes using my open source tool named Sherlock. And I'm going to demonstrate that with Lightbits storage and Intel hardware. So Lightbits in a nutshell, founded about 5-6 years ago. Lightbits is a software-defined storage solution. We invented the NVMe over TCP spec, was accepted by the Linux network special interest group. We wrote the first NVMe underscore TCP kernel module since kernel 4.10. It's been accepted by the community and been enhanced by many other storage and network providers. So Kubernetes and storage, the days that Kubernetes was mainly stateless application world are all gone. Many enterprise customers are all basing their infrastructure on Kubernetes. They're all moving their tier 1 and tier 2 applications into Kubernetes. And a lot of these applications are using databases. Databases requires mainly two things: low latency storage and high redundancy or high resiliency storage. And these are two things that you will find in need for storage in Kubernetes. Databases can be from open source project like MySQL, MariaDB, or Postgres, or Redis, or MongoDB, all the way to the more legacy database solution like Oracle and SQL Server. So let's see how Lightbits and NVMe over TCP help answer all the challenges that applications like databases need. So we have several layers of resiliency. Lightbits is a clustered solution. A minimum of 3 servers are required to run our software, going up all the way up to 64 servers. And when you create a volume in Lightbits, you basically have the ability to choose whether you want to use a single, 2, or 3 replicas of the volumes. If you choose more than, if you choose 2 or 3, then we'll keep copies on separate servers. And that's the first layer. We also have a lower layer per server where we provide the erasure coding, what we call the elastic RAID at the server level. So if you use a device at the server level, data is still intact, and you can still use that. Server. We also have another layer called intelligent flash management, which basically enhance how we write into SSDs, thus basically enhancing the lifespan of the SSDs. We have a great success doing that with Intel QLC's SSDs. So in terms of resiliency, NVMe over TCP as the transport or as the protocol detect when a target or a Lightbits server in this case is not responding, and then basically goes back into the client or the worker nodes on Kubernetes and choose the right path into an available copy of that volume. That's basically multipathing. We also saw great performance success using Intel's ADQs running on Intel's 800 Ethernet adapter series. Also using Intel Optane's persistent memory and Intel SSDs. So this is our demo, and the first thing that any benchmark tool will have is a good config file. And this one is a sample for PostgreSQL. We can see that we have 20 worker nodes. We have 6 databases per worker. You can decide the size of CPU cycles and memory that each database pod will take. And we have the PVC size of 75 gig. Where down below we also have sort of an array that maps network adapters into worker nodes. Because software-defined storage, everything is via network. And then what we're going to do is now start to run this iteration of Sherlock. We're using Sysbench, as you can see. and we're using the config file, and we gave it a name called demo 6. So it's starting to collect statistics on all the worker nodes, start to apply all the sysbench pods and run them on all over the worker nodes. Once this is done, we can run the print result file in order to view these results. Again, you can run it in iterations. Usually when you test storage, you run things in iterations. So you can either run it as a single manner or an iteration of, let's say, 20 runs of this specific storage subsystem. You can get the output in a simple manner or in a spreadsheet. And what we can see here is that 120 databases provided 9.2 million transactions. There was a transaction per second of about 128 per each database, per each worker node. This is an average on average. You also get how much network traffic went in and out from each of these worker nodes. And you also have the utilization of the PVC, or equal in this case to Lightbits volume, that each of these database pods was using. And you can see that the utilization was fairly high. That is the end of the demo. Thank you.